Hello everyone. Here the question is from the capacitor chapter. Okay, so a capacitor of a capacitance 9 nanofarad. So you need to understand the capacitance given is 9 nanofarad. Nano means 10 power minus 9. This is very important thing. You must memorize these things. Nano means 10 power minus 9 farad. This is okay. Farad is a SI unit, so you can't able to change nothing. Okay, next the dielectric slab. So here normally we will be using that epsilon naught times the medium is equal to psi. So since it is moving in the hair medium, for the hair medium this value is going to be 1 for the hair medium. Okay, sorry, hair medium. So this value is 1 for a hair medium, and the epsilon naught is a constant value. You must memorize this value, or otherwise you will be getting in the question paper itself. But it is very important, you need to memorize as per the physics. Okay, so this is 8.85 into 10 power minus 12. So what is the SI unit for this? So it's nothing but coulomb square per Newton meter square, or otherwise I will be writing like this: Newton inverse meter power minus 2. Okay, this is Coulomb square per Newton meter square. Okay, this is the SI unit for this thing. So psi, instead of psi we will be using this thing. Since this is for the R medium, the psi r is 1, but here the psi r value is given in the question itself, so we have to use this value for our further calculation. So dielectric strength is given. So this is, you have to think this is megabytes, gigabytes, you will be noting that. So 20 megavolts per meter. So what is the SI unit here is, this SI unit is nothing but the SI unit of electric field. Yes, SI unit of electric field is volt per meter. Volt per meter is the SI unit of the electric field. Now what is the given is 20 mega. Mega means, kilo means 10 power 3. We know that kilo means 10 power 3 kilo, 10 power 6 kilobytes, megabytes, and 10 power 9 is gigabytes. Okay, it is further, it will be moving to the terabytes. Okay, so this is kilobytes, megabytes. Mega means 10 power 6. So until that you understood, right? So potential difference. So we know that potential difference is B, as potential difference is 20 volt. So we have to find the area of the plate. Since here the given value is area, we have to find the area, right? So we can able to use this formula: C is equal to A epsilon naught by D. So we know that Q is directly proportional to V, right? Q is directly proportional to V. This is charge and this is potential difference which is provided to the capacitor. So now the proportionality constant will be placed here as C. C is the capacitance of the capacitor. So this C is a constant, that is capacitance of the capacitor. So first thing, this would be taken here. So we can able to derive this formula first of all, so that you can able to understand very clearly. Okay, if you have forgot it, so you can able to revise it as soon as it is possible. Okay, first thing, so between two plates, so we are already learned about these two plates. When there is a two plate parallel plate, the electric field between them is going to be, sigma is the surface charge density, and by epsilon naught. Okay, if there is another plate here, then there will be a 2 will be added. Therefore the capacitor are two plate capacitor, so that's why We are not going to write the two, only these two parallel plate capacitors. Okay, what is the sigma value? We know that sigma is equal to surface charge and density, nothing but q by area. Charge per unit area is a sigma. Okay, now this E can be written as, that is the electric field can be written as q per a epsilon naught. So further we can able to continue with, yes, we know that potential difference is directly proportional to the distance between them. So distance between the capacitor is d. Okay, potential difference is directly proportional. Here the proportionality constant is going to be the electric field. Okay, now we are going to substitute this E value in this formula so that V is equal to Q D by A epsilon naught. So we found the value of the potential difference, that is V, and finally we are going to move to the Q is directly proportional to, yes, Q is directly proportional to V. The capacitance is equal to Q by V. So we are going to substitute this V value in this equation so that you can able to get C is equal to Q, okay, Q times A epsilon naught. So nothing but here we are going to write this as Q into 1 by V. So 1 by V is value is A epsilon naught by Q D. Okay, this Q get cancelled and the remaining thing here is C is equal to A epsilon naught by D. Okay, so this formula, we are going to use this formula to solve this here. So we don't have the value of D. Instead of that we have the value of potential difference. So we know that V is directly proportional to the distance between them, that is D, and here the proportionality constant is E. To find the value of D, so here D is equal to V by E. V by E. We have to substitute this V value and the E value here so that we can able to get the answer, that is V is 20 by 20 into 10 power, here I will be writing as 10 power minus 6 after simplification. Then 10 power minus 6 is the value of this D. So we found the value of D here. Okay, A we have to find, epsilon naught is a constant value, capacitance value has been given here itself. So now what is the final thing? We are going to substitute these things. So C is equal to A epsilon naught by D. So, and another thing you must note it here is, here there is here it is not a hair medium, so we are going to use this thing. So instead of using this epsilon naught, you are going to use this value as epsilon naught times the ER, epsilon naught times the ER. So medium D. So instead of D, we found the value here is, so in here the D value is 10 power minus 6 is the value of D. 10 power minus 6 is the value of D. So finally we are going to substitute these values. So no, I will be converting this equation to, we have to find the value of the area, that is A. So I will be epsilon r is equal to A. Now our equation is ready to solve. Now the substitution can be started from here. So A is equal to, what is the capacitance value here given is 9 into 10 power 9 farad, 9 into 10 power 9 minus 9 farad. Okay, into distance between them is 10 power minus 6 pi. Epsilon naught value is the constant value, that is 8.85 into 10 power minus 12, 10 power minus 12, and ER value is given here. What is the ER value? 2.4 is given there. So I am going to substitute that value 2.4. So now the simplification process can be start from here. Okay, what we can able to do here is we can able to write this as 8.9, so 2.4 So 10 power minus 6 is remains in the down position, this is denominator position. So 10 power 3, 10 power minus 3 is going to remain in the numerator. Okay, now 9 by now what we can able to do here is 8.85. I'll be 8.85 is approximately it is going to um, approximately it is going to equal to 9. Okay, approximately. So I'm doing the approximation value here, so nothing is wrong here. 10 power minus 3 can be written here and approximately. So 2.4 can be approximately written as 24 into 10 power minus 1. Okay, now let us cancel this thing. So it's 1 1. So now a is equal to 10 power minus 2 into 1 by 24, 1 by 24. So since here is 24, we can able to approximately it is going to equal to, so approximation, we are doing the approximation here. Approximately it is going to be 1 by 25, 5 into 10 power minus 2. Okay, now approximately it is going to equal to, approximately it is going to equal to, here there is 4 will be 0.4 will be the answer. 0.4 into 10 power minus 2 is going to be the answer for this value, that is approximately 4 into 10 power minus 3. Okay, so this is the value of the area of this capacitor. So thank you.